Hello?
Oh.
Okay, alright, so, okay, find definite integral using substitution now. So, first thing I'm going to say, I'm going to look at that and I'm going to say what? Nope, try again. Say F that.
F that.
Okay, what can we F out of that? Nope. 1 over 2, right? Okay, so I'm going to take out a 1/2, and I'm going to bring it out front, right? Okay, so it's going to be equals, it's 1/2 integration from 0 to pi over 2 of 1 minus cosine of 2 theta d theta. Now, in this case, we could also use the fundamental theory of calculus and separate my two terms. I'm going to separate my two terms. So now I'm going to say 1/2 integration from 0 pi over 2. Hey, shh! I don't want to hear your drama. 1 d theta minus 1/2 integration 0 to pi over 2 of cosine of 2 theta d theta. Now, did I lose anyone on this? Okay, I am trying to go through this kind of with the quickness, but I really need to get it done. All right, so this first one right here, the first one's going to be integration. That's going to be a pretty simple one, right? I'm going to have 1/2. So let's do the integration for this first. So it's 1/2 what? Nope, 1/2 what?
X.
It's not x.
Theta.
Theta. So it's 1/2, right? It's going to be theta, right? From 0 pi over 2. Okay? All right, good. I'm just setting that up. I'm trying not to skip. All right, so now the problem that we have this. Remember what I said? If I look at it and I said, hey, I would have to do the chain rule to do the derivative, right? So chain rule derivative means what? Substitution, right? So I'm going to u sub. Now, what am I uing on this next one? 2 theta. So it's going to be u equals 2 theta. D theta is equal, or I'm sorry, du. So du is going to be 2 d theta. Now, to get that 2 out of there, I got to do what? Divide both sides by 2, right? So I'm going to replace my d theta with 1/2 du, right? And that 1/2 is going to come out front, isn't it? But I already have a 1/2 there. So when I do that, what's that going to do? If I'm factoring out another 1/2, what do I have? 1/4. So I'm going to have 1/4 now out front. So it's going to be minus 1/4 from. Let's see. Do you want to keep the balance or do you want to u sub the balance? Do you want to u sub the balance? Because we went over this yesterday. I could do it and put it back, or I could u sub my balance also. So instead of doing my balance from 0 to pi over 2, I could do my balance from. Okay, let's look. So if I plug in 0, 0 times 2 is, so the lower bound would be 0, right? And then if I put in pi over 2 times 2 is, what's 2 times pi over 2? Pi. So my u bound here would be pi. Yes. I'm just trying to show the steps for this. Okay, for all those people in Nicaragua that's actually watching this right now. Okay, all right. Nicaragua. All right. It's a country. I'm nationalist. I'm not racist. It has nothing to do with the race. It has to do with the nationalism.
Nationalism is not the best thing either.
Because America. Yeah. All right. So this is going to be cosine of u du. All right, let's go continue my steps. All right. So right here, this is going to be, let me see. So if I plug in the top, it's going to be 1/2, right? Minus 0. Yes? Okay, 1/2 times 1/2. So this is going to be pi over 4, right? Pi over 4 minus 0. Yes? Minus. All right, what is the integration of cosine? Positive sign. Positive sign, right? Positive sign. So it's going to be positive sign. Okay, so let's see. So I'm going to bracket this again so I'm not skipping steps. Okay, so it's going to be positive sign of u from 0 to pi. Okay.
And the answer is pi over 4. Yeah, it's just pi over 4.
Okay. Because you're saying, all right, so what if I did not u sub this? What if this was still sine u, but I was going to here. So if I was using pi over 2, that would have been 1, right?
Yeah.
Okay, so if I would have did that, so let me see. Without the bounds changing, so that would be 1 and minus 0.
Pi over 4 minus 1 over 4. It just.
Don't forget, it's going to be, it would have been double anyway. Wouldn't it? Page. So my integration was what? From 0,
Pi over 2.
pi over 2, and that's going to be, was it cosine?
Cosine of 2 theta.
Okay, 2 theta d theta, there was 1/4 out here,
No, it was.
right?
No, it was 1 over 2.
1/2, okay, yes, it was 1/2. Okay, so let's redo this, okay? So let's just not sub the bounds it. Okay, so I'm saying u is 2 theta, du is going to be 2 d theta, so we get 1/2, right? Okay, so right here, I'm still 1/4, right? Integration, 0 pi over 2, 0 to pi over 2, cosine of u du. So I'm not subbing the bounds. So that's going to be sine, right? 1/4. So sine, right? Okay, so it's going to be sine of, okay, put it back in, to theta from 0 to pi over 2.
Okay.
So, top, what is 2 times pi over 2?
Okay, it's going to be 0.
There we go. We get the same thing, right?
Yeah.
So, that's what I'm saying. So you could use sub your bounds and actually save you some work. All right, so now this is going to be 0, 0. So this is my answer. Just comes out to be pi over 4. Okay, integration, even and odd functions. Integrals of even or odd functions can be simplified due to symmetry. Illustrates conditions of theorem that follows. So now if it is even, that means that I am going to have right here from here to here, okay, it's going to be double whatever this is. So from 0 this way is times 2. It's symmetrical. Because quite often where it's not going to look like this, it's going to look like this. And if you're taking it here, you get a 0. If you're taking it here, you get a 0. So that's the problem. And that's the reason why most often when we have these, you have to do symmetrical. You're going to have to on those. Okay? And same thing here. When it is odd, it's going to give you a 0. Because that means that from here to here, this is a negative. and it is symmetrical, but it's on the other side, and this is positive. So the negative and positive together should cancel out to be that 0. Okay? All right, so whenever we see functions like this, we're going to get some of these when we're actually talking about the rectilinear motion, where we're talking about, hey, this is going to be going, remember, walking from here to Douche Bros. Remember that? Yeah. Okay, so my total distance traveled would be the absolute value from here to there, right? Of the function of here to there. Because I'm going there and I'm coming back. So I have a negative velocity coming this way, and I have a positive velocity going that way. So that's where I get the absolute value. So if I absolute value this, this is going to look like this. Make sense? Okay, so that's the reason why we're going to have to do stuff like that. Okay, so theorem integrals even and odd functions. If it is an even function, then it's 2 times from here to here. Now, why does it go from 0 to A?
Because the half of it.
It's right at half, isn't it? Is it possible to be symmetrical not at the 0? Yeah, it's possible to be symmetrical not at the 0. So
How do we know if that function is even without a graph? It's a good question. Oh, makes sense. Okay.
all right, you guys ready for the hands?
Yeah.
All right, with the arms. Let's do the arm dance right here. All right, so show me x squared. Everyone, x squared. Okay, show me x cubed. X to the 4th.
I don't know.
X to the 4th. They both go up. That's an even, right? Yeah, it's not as wide, right? So x to the 5th. Faster, going almost straight up, right? Absolute value of x. There we go. And now, show me square root of x.
Isn't that like?
Just one side. All right. Okay, good.
Wait, why can't you read sign?
All right, so let's go ahead. So this one right here, is this first one going to be an even or an odd?
Odd.
It's an odd, right? So what is the answer going to come out to be? Is it from here to here, right? Okay, so from there to there, I'm going to end up with 0 because it is going to be an odd function, isn't it? So if I do that, okay, it's going to be odd function. This one should be asymmetrical, right? So if I do the math on it, let's go ahead and do the math on it then. Okay, so that's going to be from, let me see, I have x to the 8 over 8 minus x to the 4th plus x squared over 2 from negative 3 to 3.
So we can change the bounds from.
I'm not changing the bounds. Is this even or odd?
Yeah, it's
So the function of this is going to be even or odd.
even.
All right, so now let's take a look. Let's plug it in. 3 to the 8th power. Is that an even power?
Yeah.
Okay, so I don't know what 3 to the 8th power is,
But it's gonna be
but is it going to be positive or negative?
positive.
That's going to be positive, right?
Yeah, I'm pretty positive.
Okay, so it's going to be positive. So someone help me out.
Okay.
Oh, you want to
Do the math.
3, 9, 27, 81,
6,561.
6,005 what?
561.
Okay, so it's basically, if I do the math correctly, it's going to be 81 squared, right?
Yeah.
81 squared. So, yeah, that's what we come up with here. Over 8 minus 81 plus, and what's that going to be, 9 over 2? Okay, so it's all of this minus my lower bound. So it's minus the lower bound. Minus the lower bound, right?
Which is gonna be absurd.
Which is a,
Same.
okay, because it's a negative, right?
Yeah.
Okay, so when I take that number and I take it to an even power,
It's gonna be same.
it's going to be positive, right? Okay, so let's take a look. So that's going to be a positive. So that's going to give me
6,000.
6, 5, 6, 1 over ocho minus ocho uno. Then we have 9 over 2.
Really?
Okay, hey, look.
Oh, it's
Oh.
0.
That's why we get 0.
So it's
Was this an even or an odd function?
odd.
It was an odd function, isn't it? That's why I said starting out the function. I'm not talking about the integration, the function. Okay? Not f prime, but capital F. All right, so let's do this next one. So this next one says we have,
Even.
should be an even, right?
Yeah.
Okay, so if this is an even function like this, so therefore I need to do what?
Change the limit. Oh my god. Bounds, yes.
Okay, so now I'm going to show you why. I'm going to show you what's going to happen here. So let's take a look. So this is going to be x to the 5 over 5 minus x cubed over 3 plus 3x from -2 to 2. Okay. Let's do the math.
32 over 5 minus 8 over 3 plus 6.
Plus what?
6.
Okay.
And then minus
Minus
negative 32 over 5 plus 8 over 3.
32 over 5, right?
Plus 8 over 3. And minus 6.
Minus 6, yeah.
So it's just gonna go
Now,
double.
because I put the signs, and there was a minus sign right there, and I have to distribute that negative, when I distribute that negative, this is now positive, this is now going to be a negative, and that's now going to be positive.
So it's gonna be just double.
It's double what I'm doing, right? So that's why we could take it and go, oh, hey, let's just do the bounds, change the bounds, 2 times 0 to 2. Easy? Okay, good. All right, if f is an even function and this is -6, this is +8, find 5 to 2. So even function means it is symmetrical, right? It's symmetrical. So if it's symmetrical, that means, let's take a look. So from 2 to 6, right? So I have, let's say number line. All right, 0 and here to here. So 0 to 2 is going to be -6, right? Okay. That's fine. Okay. And from -5 to 0 to what? To 0 is 8.
Can we find from 2 to 5?
And I'm looking for this one right here, right?
So it's like,
So if it's symmetrical, right?
so it's gonna be from
If
0
it's symmetrical from -5 to 0
So it's gonna be from
should also be, all that right there should be what? 8. Because symmetrical, right? It's going to be the same as the left as on the right. So this is going to be ocho, right? If that's 8, the whole thing together has to add up to 8. That means from 2 to 5 has to be,
14.
why is it 14?
Because 14.
Because it's going to be, let's do some algebra here.
Oh yeah.
Woo! All right, so
Okay, go.
x minus 6 equals 8.
Oh yeah, it's a good one. X is
Wait,
equal to
wait,
14.
wait.
It's right. It's right.
Yeah.
Were you?
Just.
Wow. Okay, plus 6, x is 14. Now, you guys feel good about this now? Okay.
This one was good.
That was good? Okay, good. All right, don't forget, like, share, and subscribe.
This one for this question,
Yeah.
you can stop the video.